Okay, so let's go over two examples of how to solve inequalities containing absolute value. And these are tricky to set up. Now, the good news is that that's the only part that's tricky. So when it comes to solving and graphing, that's really the easy part at this point. It's really just setting this up. And so before we do any of that, we have this quantity here, 3 minus 2r is in the absolute value. It's greater than 7. And I just want you to think about for a second. I'll take my sticker here, just cover up this expression. Let's just think about absolute value in general here. What absolute values? Think about what numbers could I put in here that would be greater than 7? Start with some positive values, right? So think of some positive values that would be greater than 7. Numbers like 8, 9, and 10, right? Really just anything larger than 7. So that's half my solution, right? I know that part of this solution set is going to contain values that are greater than positive 7. Like I said, 8, 9, 10, 11, etc. Now, remember, absolute value can also be negative, because if I put, say, a negative 8 in here, well, the absolute value of negative 8 is positive 8, and 8 is greater than 7. So now ask yourself, okay, well, what negative values would make this statement true? Well, that'd be numbers like negative 8, negative 9, and negative 10. In other words, numbers that are less than negative 7. So I changed the sign of this 7 and I flipped the greater than around to a less than, because I know that anything less than negative 7 is going to make this statement true. So this part here just stays the same. The tricky part is flipping this around. Now I'm going to move my little sticker away and we'll just set up these problems. So we have 3 minus 2r is greater than 7, and we have 3 minus 2r, same expression, is less than negative 7. And now we just solve and graph. So here we go. We're going to subtract 3. So let's look here. We're going to get negative 2r is less than negative 10. And then r is greater than 5. Over here, I'm going to get, well, I'm going to subtract 3. So we get negative 2r again. Negative 2r is greater than, well, 3 from 7 is 4. And then we're going to get r is less than negative 2. And now we just graph the solution set. Okay, so r is less than negative 2. Okay, so leave that open circle. Values of r that are less than negative 2 will complete this statement. Values of r that are greater than positive 5. So there you have it. There's the solution. Values that are greater than 5 or less than negative 2 all will make this statement true. And remember, anytime you see a greater than sign, it's always going to resemble one of those OR graphs where you have two rays essentially going in opposite directions. Okay, one more example. We now have the absolute value of 2x plus 1 is less than 5. And just like we did with the first example, I'm going to cover this one up, right? So just imagine I'm holding this here. I'll enlarge it a little bit. We're covering this up. I just want you to think about absolute values. Okay, so let's start with the positives. Okay, what are some positive values I can put in here whose absolute value would be less than 5? Okay, so we're thinking of like 1, 2, 3, and 4, right? Or 4.8 if you want to include decimals. Remember, anything less than positive 5. So that's going to be half my solution. And now we got to think about, okay, well, what other numbers, what negative numbers will make this statement true? What negative numbers, if I take their absolute value, will still be less than 5? So now you're thinking of numbers like negative 4, negative 3, negative 2, and negative 1. In other words, anything greater than negative 5. And once again, this is the tricky part to set up. Half the problem stays the same. We're going to leave this less than 5, less than 5. It's setting this up. Understanding that all the values greater than negative 5 also make this true. And then from here, we're just going to plug in the rest of the problem. Okay, so 2x plus 1 is less than 5. And 2x plus 1 is greater than negative 5. And we'll solve from there. So I'm going to get 2x is greater than negative 6. X is greater than negative 3. Over here, I'm going to get 2x is less than 4. And then x is less than 2. And now we graph our solution. Okay, so x is greater than -3. Okay, so here's -3. Open circle over that, so it's going to be going this way, right? I'm going to hold off on shading the whole graph here. And then x is less than 2. Okay, so that's going to be here. So remember, it's this overlapping region. It's this union right here, where x is greater than -3, but less than 2. And just like we did with compound inequalities, this sort of resembles, anytime you see a less than sign, it's going to resemble one of those and statements. Like when we solved graphs that had, x is greater than y and less than z. Well, it always makes a graph that looks like this. Okay, so there you go. Those are two of the examples, and we'll do more when we meet this morning.